Okay guys, good morning. This will be the last piece of lecture type notes that we do before spring break, so yay for that. We're gonna just talk about squares today, and actually there's two problems that deal with rhombi, so we'll get a little bit more practice with those as well. And then on Friday, I'm gonna post a video of me going over a bunch of problems, but then also I'm gonna have live video conferences each class period if you want me to go through them one-on-one or face-to-face through Google Meet or whatever, because I know some of you are really missing the whole face-to-face classroom type setting. So today we'll start with squares. The cool thing about squares, I think they're actually the easiest of all the ones that we've learned, because a square actually has all the properties of a parallelogram, a rectangle, and a rhombus. So we don't have to remember any more properties. We just have to remember that all of these ones that we've already talked about apply to a square. So really, if you think about it, you could classify a square as a parallelogram, a rectangle, and a rhombus, but none of these three things can be classified as a square. A square is like the smallest classification you could get when talking about these groups of quadrilaterals. So later, probably after spring break, we're going to kind of make a map of how these all fit with a few more quadrilaterals that we'll get into. But for now, this first little box is all the properties of a parallelogram. So if you don't have those down somewhere, I hope you do. So these are all parallelogram properties. Then the rectangle properties are that it has 4 right angles and the diagonals are congruent. And then the last one, what we learned yesterday, rhombus, they have 4 congruent sides, the diagonals are perpendicular, and the diagonals bisect opposite angles. So all of those properties, they're specific to those quadrilaterals, but they're also all true for squares. So if I look at this first problem, I have, if ABCD is a square and AD is 11, that's all they're going to tell me. AD is 11. Find each missing angle. So first off, we know for squares that each square has a 90-degree angle, or it's made up of 4 90-degree angles. Now, the other thing about these 90-degree angles and these diagonals that we should know, that I want to point out before we get into this, is since these are 90 degrees and these diagonals, the diagonals are bisecting the opposite angles. So these diagonals are bisecting these angles. That's going to split these 90-degree angles into even 45-degree angles. So right here is 45 degrees and right here is 45 degrees. And that's true for all the way around. Okay? So that's why I kind of think square is the easiest, because really the main thing you have to think about are 90-degree angles and then 45-degree angles. So looking at these problems, to find BC, BC is just this opposite side. So I'm actually going to get rid of all these angles except for one. So BC is just the side of the square, which we know squares have all congruent sides. So BC is 11. AC is a diagonal. So the diagonal, we don't know if that's 11. That's not necessarily congruent to all of the outside perimeter sides, but instead, remember we have a right triangle here. So we're going to take 11 squared plus 11 squared equals x squared to find that diagonal, that highlighter green. And so 11 squared plus 11 squared gives me 242 equals x squared. And then I'm going to take the square root to solve for x. So I get 15.6 for x, or that's my diagonal. And then BD. BD is the other diagonal, so BD is this diagonal. If I look up at my properties, This red highlighted one, diagonals are congruent. That one is true for squares as well. So I can say BD is also 15.6. I want you to really pay attention to which property I'm using to find each of these, because that's going to be a big thing in your quiz today. I'm going to say, hey, what properties were used for number 7, or what properties were used for number 6, and so on and so forth. So for EC is half of this green diagonal. So I'm going to take half of 15.6. So 15.6 divided by 2. And I would get 7.8. So half of one of those diagonals, actually half of all those diagonals, is 7.8. Now I'm going to work with my angles, so I'm actually going to erase this stuff, because this is all to do with my sides. And really the only thing you should know is these 90-degree angles, because again, the diagonals are perpendicular to each other, so they're creating those 90-degree angles here. And then on the square itself, there's a 90-degree angle at each corner. And then since my diagonals are bisecting the angles, that's creating 45-degree angles at all of these little spots in here. Okay, so hopefully that makes this pretty easy for the angles. DAB, that's just one of the right angles of the square, so that's 90 degrees. AEB, that would just be one of those 90-degree angles formed by the diagonals that are perpendicular. And then CBD. So CBD is this angle down here. That is where the right angle is being bisected by the diagonal. So the diagonals are bisecting the opposite angles there. So 45 degrees. And the last one, BAC. Again, that's looking at that angle, that right angle that's being bisected. So 45 degrees again. Okay, what I want you to do is try 7 on your own, and I'm actually just going to write in the answers because I don't think I need to explain as much, but after I show you the answers, then I'll kind of like go back and show you, hey, this is how I set up my equation. Okay, so here I got my sides already. So for PR and QS are the diagonals. I was only told what half of the diagonal was, so I had to take 17 times 2 to get the full length of PR and QS. QT was just half of the diagonal again, so that's 17, just like TR. And then for PQ was this side, the outside perimeter side of the square. So to find that outside perimeter side, I had to use Pythagorean theorem by knowing that half of the diagonal would be 17 for this side and then 17 again for this side. And remember that this is creating that right angle, making PQ your hypotenuse that you're trying to solve for. Okay, now I'm going to do the angles, so pause. Okay, so for this one, again, the only answers I got were 45, 90. So for angle PSR was, PRS, sorry. That is one of those angles that's being bisected by the diagonal, so that makes it 45 degrees. STR is that perpendicular angle formed by the two diagonals, and then the PSR is just an outside, not an outside, but one of those right angles making up the square. And then QPR is one of those other angles that are being bisected, making that 45 degrees. Okay? So now for 8 and 9. 8 and 9 are actually rhombus questions. So if you want to try those really fast on your own without me to see what you remember and then come back to the video. Before I start 8, I wanted to point out again that my rhombus those are the green properties. So because a rhombus has these properties, we remember that a rhombus has these 3 additional properties as well as the properties of a parallelogram, but it does not share these 2 properties that a rectangle has, okay? So we cannot assume that there's 4 right angles and that the diagonals are congruent. We can only say there's 4 congruent sides, diagonals are perpendicular, and they're bisecting those opposite angles. So that's something to keep in mind when we look at number 8. So already I see in number 8 that I'm dealing with side lengths. So I know that in a rhombus, all these sides are congruent. So I can say this and this are congruent, as well as here and here. And I want to find MP. So luckily MP is one of the outside sides. So knowing that I have MN and PO, MN and PO should be congruent to each other because they're both the outside sides that make up this rhombus. So I'm going to have 9x minus 77 equals 3x plus 7. And reminder, the reason why I set those two equal to each other was because of that property that says a rhombus has 4 congruent sides, okay? That's really important. 4 congruent sides. So then when I solve for x, I'm going to add 77, and I get 9x equals 84 plus 3x, subtract 3x, and I get x equals 14 after I divide 84 by 6. Now I'm going to use x equals 14 to find MP by just taking x and plugging it into either of these sides. Both of these should add up or equal the same thing, so it doesn't really matter. It's just whatever you're more willing to look at. But I'm going to do 3 times 14 plus 7, which is 49. So MP equals 49. Again, the whole reason why I was able to solve for this was because I knew that there were 4 congruent sides in a rhombus. So I set the 2 sides equal to each other that I knew. Okay. Now looking at number 9. So we're still dealing with a rhombus. And I'm finding angle FED. So angle FED would be this angle right here. Now, if I look back up at my rhombus, already I want to see which one talks about the angles. Well, that would be this one. The diagonals bisect the opposite angles. So that means that this angle and this angle should be congruent to each other, okay? So I'm going to make little tick marks. So since those 2 angles are congruent to each other, I then have 2 equations that I can set equal to each other so I can solve for x, okay? The best way to solve for x is to have 2 formulas, and then if you know they're equal to each other, then you can eliminate things to get x by itself. So I'm going to add 20. Subtract 5x. And 21 equals 3x, divide by 3, and x equals 7. So now I can take x and I can plug it into either one of these angles. So let's plug it into, let's do this one. So 5 times 7 plus 1, and you would get 36. So both of these angles are 36 degrees. So together they would be 36 plus 36 equals 72. So together they're 72 degrees. So I'm going to make note of that on my picture. Maybe. This thing is going really slow today. Okay, so the other thing that we're going to look at in my properties, I don't know, I definitely don't have 4 right angles. These are all my rectangle properties, so I'm not going to look at those. 4 congruent sides, diagonals are perpendicular. None of those deal with angles. I already used this one. Now we're going to look into my parallelogram properties. Opposite sides, opposite angles are congruent. I don't really have, if I look down back at my picture, I don't have anything. Saying opposite angles are congruent doesn't really help me because that would just mean this angle right here is congruent to this angle over here. So I want to talk about, what is the property for 2 consecutive angles in a parallelogram? Hopefully you remember, but if not, it is up here. And it says consecutive angles are supplementary. So this yellow angle that we have down here plus this red angle should add up to 180. So I'm going to take, that's what supplementary means. So 180 minus 72, and I get 108. So this red angle is 108 degrees. Okay, that is because these two are supplementary. They're consecutive angles. They're right next to each other. Okay, so measure of angle, FED, equals 108 degrees. 10, we're dealing with squares again, and I'm given SW is 2x plus 13, and WU is 8x minus 41. So the thing about squares is that their diagonals are congruent, and then their diagonals are also bisecting each other. So that means this gray section should be congruent to this red section. So I'm going to take 2x plus 13 and set it equal to 8x minus 41. So I'm going to add 41. Subtract 2x. And divide by 6. And x equals 9. Oh, that's really bad. So now I need to use that to find VT. So VT would be this entire diagonal. Okay? So if I could figure out what SW is plus UV, or letters. If I could figure out what SW is and add that to whatever WU is, that could tell me the exact length of VT because these should be the exact same length. Okay, so I'm just going to plug in 9 for both of these equations and add them together. So when I plug in 9 for SW, I have 2 times 9 plus 13, which gives me 31, and that would be SW. And then for WU, I have 8 times 9 minus 41, which I didn't really even have to do that because it should be 31. Duh. Because these are both going to be congruent. But we just showed again that they're both congruent. So now to find VT, you could either add 31 twice or multiply 31 by 2. And you get 62. Okay, so in this one, the properties that we used were the diagonals bisect each other and that the diagonals are congruent to each other. Okay? All right, 11 is really short and sweet as well because, again, this is a square, so whenever I'm dealing with angles, the only two angle measures that you should have are either 90 degrees or 45 degrees. So if FGHI is a square, solve for x. Well, the angle that this is pointing to is just this small piece. Now, that should be that 45-degree angle because this is a right angle. This angle of the square is a right angle, and then this diagonal is bisecting that right angle, making it 45 degrees. So the property that you would use technically in this problem is this diagonals are bisecting opposite angles, and then there's 4 right angles, okay? So 4 right angles, and the diagonals are bisecting those opposite angles. So I'm going to write that because that is important. So 4 right angles and the diagonals are bisecting those opposite angles. Okay, so make sure you have that. Store it, something. So I'm going to have 7x plus 3 equal to 45 degrees. And I'm just going to subtract 3. 7x equals 42. Divide by 7. And x equals 6. And you're done. Okay, so all you have today is an attendance quiz. It is going to ask you very specific things over these notes, so hopefully you took pretty good notes. Yeah, if you want to join the conference tomorrow to go over some problems live, face-to-face, let me know, so I'm sure to stay on the whole time because typically if I don't see anyone joining for like the first 15-20 minutes, I'll just end it. Because I don't really want to be sitting in front of my computer that whole time. So if you're going to join and you're going to be late, let me know. Okay? All right. Hope you guys have a great rest of your night and talk to you soon.